Welcome back. And now we start with the Docker services. Any questions that you might have from the previous slides?
Okay.
Faros, please.
I want to ask, can I use many containers, many servers in one container, or I must to have every service must to have one container, or also some in one container?
We're going to cover it now. That's what we're going to just cover now. Docker services. In a distributed application, different pieces of the app are called services. For example, if you imagine a video sharing site, it probably includes a service for storing application data in a database, a service for video transcoding in the background. After use, upload something, a service for the front end, and so on. Services are really just containers, to answer your question, but they're in production. A service only runs one image. But it codifies the way that the images run, what ports it should use, how many replicas of the container it should run. So the service has a capacity it needs, and so on. Scaling the service changes the numbers of the container instances running that piece of software, assigning more computing resources to the service in that process. What does that mean? Is that although you have one container, there is an algorithm in the swarm that replicates your container to make it more available.
Okay.
Does that answer your question?
Yeah.
And how?
Thank you.
You're welcome. Well, one of the very simple ways is you write the instructions what to do. And the instructions can be written in YAML. It is a very simple instruction. It can get a lot more sophisticated than that. Docker service implemented the containers as a cluster with a selected configuration on production systems. So here you have the version services is a web. That's your image. Deploys 5 replicas. That can be 25, 100. I don't know the max. We have to look at the manual to find out what the max is. And the condition on the failure, restart. And here where you can see, you can define your CPU as well at 0.1. And memory at 50M. Ports, so you don't have to give it -p anymore, you can define it here. And the network is a web net.
But, sorry. Let's say I want to have 5 replicas. I don't really get how they can have the same ports. They should have different ones if I use them all for the same purpose. But I want to distinguish between them. Let's say they all deliver some website, whatever.
Naturally, then there will be a more sophisticated way to plan it.
So in this case,
Is a replica exactly the same?
Yeah, but in this case, 5 replicas would all use port 4000, and then
Exactly.
that would get us into trouble, wouldn't it?
Well, not really, depending on your system. For that particular system, when you say 4000, when it comes in, then the swarm distributes it between the calculator.
Ah, that's what Docker itself is doing then.
Swarm is doing it, yes. Because before we didn't run Swarm, we're going to run Swarm now. Because you run Docker, then you say Docker Swarm init. Then there will be extra process to manage your distribution or load balancing between your virtual nodes. But this is not a virtual node at the hypervisor level, it's at the Docker level. You will see it soon. There will be multiple nodes that they are not managed by the port anymore. And how they manage? So you say Docker Swarm init. In this particular case, I had to identify the advertised address. Reason being is all of our machines are Windows here, and I was forced to run a VirtualBox on top of it. VirtualBox, we had to do some bridging between the Windows to VirtualBox. So in this particular case, you have to give the IP because the Docker is getting confused, doesn't know what is Windows, what is the CentOS. But as soon as you give the managed as advertised, if you are doing it on your VirtualBox, that's absolutely necessary. Otherwise, it's not going to work wrong. So the swarm says, I'm going to get the messages from this address at port 4000 to be able to distribute it and load balance it. And afterwards, if you want to add worker to the swarm, all you do is Docker swarm join, and you give the token. And you have to memorize this token. No, I'm just joking. Every time you run it, it will give you the token, so you just cut and paste it, or you copy it somewhere. So you can add more to the swarm. Now, the swarm has nodes and it has managers. Managers, they manage other swarms. They have permission to subtract and add. And if you want to manage it, then you have to give it a different commands to do that. Right, your swarm is running now. But this time, instead of saying docker run, we're going to say docker stack deploy, because we're going to deploy a stack. Stack of how many nodes was that? It was 5. So we're expecting 5 nodes to be coming in the stack automatically. So docker stack deploy -c, look at my docker compose YAML, and we call it Redis access again. So it's the same application. Creating network, creating service. So it's got its own networking system. It's got its own servicing system. So here we're outside the TCP/IP domain. And you can say Docker service ls, so you can see what sort of services you have. Here you have the ID, name, replicated, how many, and the image, which we are pulling from Docker Hub, and the ports. Although you have 4,000 going to the 80, you have 5 nodes here. Which means if you do docker container ls -q, you get the name of the nodes, and every time you refresh your browser, you will have a different hostname. And this hostname is part of this. And you can see this hostname doesn't exist in here because, again, it's from a different example that's been cross-referenced.
The symbol, the same was a web cluster? Can you
repeat the question, please?
This construct, what you do, what you can create, I remember that you see this can be a cluster of a web server.
Yes, exactly. Yeah.
Okay.
Yeah. You're load balancing your services through a web server without having a web service, without having multiple IPs.
You don't know hardware or
Not necessary. Now, this gets more interesting because in the services, what you're doing here, you're using the Docker internal services that is made at the memory level, but you can have it more sophisticated, which we're going to cover in a second.
But you need a very, very big area in the AWS or cloud.
We'll cover it in a second.
Okay.
So after this, if you want to clear it up, there are lots of commands and CLIs. We're not going to cover all of it because it's not necessary. You can do them manually. But here we are covering a couple of important ones. In this particular case, you just do docker stack rm redis access. It just gets rid of it, removing services, removing network. Everything is out. Then you have to do docker swarm leave ---- force. So then the swarm algorithms are stopped. So yeah, everything is gone. But for some reason, you have to use ---- force. I cannot explain why at this point. Now, related commands. Here we have a bunch of commands here that we're going to quickly cover, but you can basically look at it while you're working with a command line interface. In the swarm nodes, demote, inspect, ls, promote, ps, rm, and update, which is very self-explanatory. Here you have deploy, ls, ps, rm, and services for the Docker stack that you have. Because the Docker stack, if you don't use the YAML, you can give the flags directly as well if there is no YAML. Then you have Docker image and Docker container. The container has got the most commands in there. But all the useful ones we already covered, and the rest is very self-explanatory. I explained it to you in front.
I'm just curious, line promote in the swarm commands.
Demote and demote?
we have promote here.
Demote and promote, yes.
Promote would mean one of the containers is being promoted to be the managing container, which could translate maybe just like if you have a master slave server.
Exactly.
Or something.
Exactly.
Okay.
The master slave, it gets more intensified when you get to the Kubernetes.
Mm-hmm.
Exactly. So I'm saying it's just a repeat. Kubernetes is just a repeat of the Docker, but in a larger scale. That's why it's very important to understand the Docker internals. And we still are not covering the whole internals here. It can be a lot more detail in there, but I don't want to go into that sort of depth in this particular lecture. So here it gives you some simple diagram about the swarm routing. So you can see 8080, this is like a Tomcat, going to the swarm load balancer, exactly to answer your question. Then it goes to the my web 10.0.0.1, 10.0.0.2, and node 3. Now, where did this come from? We'll cover in a second. So in the services, we didn't have nodes. We had these host names. Now it is possible to run it as nodes. So these nodes, although they are similar to VMs, they're not really VMs. They are VMs of the VMs. Why? Because the CLI comes into the swarm managers, and the swarm managers connects to the agents. And depending on what sort of agents you have, swarm will work differently. But doesn't matter if you're using services or you're using nodes, you need the swarm. So the swarm is built for both of them. So all you do is you just do systemctl start Docker, Docker swarm init. So you activate it within the Docker. Then you can have either nodes or you can have services. We just explained the services section. Now, in order to create the nodes, you need to have a virtual box. So, in this particular case, we have a VM of a CentOS. So we have to download the virtual box to have these individual nodes within their virtual box. Then what Docker does, uses these virtual boxes to create the nodes and run the swarms on top of them. So they don't redo the work that the virtual boxes does. It just uses the virtualization of the virtual box. Now to do that, you just do a wget the virtual-box repo. That's how the yum functions. If you want to have yum updates, you first have to download the repo in the /etc repo yum repo repository directory. And when that is downloaded, you need to enable EPEL. Everybody's acquainted with that? Yes? EPEL, everybody knows what it is? It's extra packages for enterprise Linux. Because the CentOS is open source, so yes. For the enterprise Linux you have to download these packages. And in this particular case we need the DKMS as well, which is a dynamic kernel messaging system. And DKMS is used for VirtualBox, to creating the virtual boxes, virtual machines. And here you can see it does finds out the dependencies and does the installation for you. And that's an Oracle product, so you can see it's downloaded from the Oracle. And these are the necessary libraries that it's downloading as well. And it calculates all the dependencies. That's the beauty about the YAML. You don't have to worry about the dependencies. And now, when it's installed, you have the VirtualBox on your CentOS. Now, again, this is a problem which is related to Deconium, because what I've found out is when the Docker machine was created, when the VirtualBox was created, I ran the Docker machine to create my VirtualBox machines to be able to put it into the swarm. And when I did that, it told me that there is an error. Please activate the VTX AMD V in the BIOS. And I accessed the BIOS, it was activated. Then we had a look at the VirtualBox, it was activated. And after a lot of research, I found that you cannot have double virtualization. So if you're trying to test this, if you do double virtualization here from the Windows to CentOS, and then to try to create the Docker machine is going to fail. Docker machine needs the virtual box to be created on a real CentOS virtualization and not replicated. So double replicas will fail. So I couldn't continue here, but luckily we had AWS. But I didn't give up. I continued, went to the Docker site and just copy and paste how they basically created the Docker machines there. So here you can see you have two virtualized my M1 and my VM2 and VirtualBox as a driver running as this is TCP/IP and this is TCP/IP address in a swarm. So now you have the nodes in the swarm. So if you have a system that it's a little bit more demanding, then you have to have the VirtualBox to be able to run on separate nodes. And when that is created, then you can join the swarm one by one, as many as you want. And since they are machines, you can actually SSH into them, or you can run a remote SSH command. In this particular case, you say Docker machine SSH my VM1 Docker node ls, and you can see the list of the Docker node in there. Now, in this case, you have leaders and slaves as well. Here, you can see this one is the leader. Now, before I go to the AWS container solution, since we could not achieve that on our servers, what I can quickly show you is if you go to the Docker site, you actually can see the construct of the machines. So we quickly go through that, so you can see how it's done. So these are the Docker machines that we created. These are the nodes, you can see the leader. We just covered it up to this point. That's their application called Get Started Lab. We had Redis, my web Redis, and that's a YAML. So everything is the same except the Docker machine is running in this particular case. You can do SCP of the MyYAML to every single individual node to be able to run the application. So that's not automatically distributed like the services. The services, they all know of the application. But in the Docker node, you have to do it one by one. Then you have to deploy it, which makes sense. It's like when you do deployment to every single node that you have currently. And that's your stack. This is repeating it. And deploying it. And that's it.
F5.
It goes back to the first.
Oh, okay.
There's another one that got directed to that. Okay, AWS container solution. In our previous lecture, we covered many aspects of the infrastructure as a service on the AWS, and we're going to be revisiting it now. And I'm going to go through it very fast because you already know how it works. But you will see the power of the AWS in this particular case of containers and Docker. So the step one, the container and task, this is the diagram of the ECS. So on the AWS, they refer to it as ECS for the Docker. You have the container definition, task definition, service definition, and the cluster definition, which we have already covered it. So here is very easily encapsulated and you don't have to go into that depth, but when you have the understanding how it works, it's a lot easier to manage it when you are on the AWS. That does not mean that you cannot do it on the EC2. You can do it manually on the EC2 and do it. This ECS will cost extra, but you can see how easy it makes it for you. Here you have the sample app. You can run Nginx, Tomcat web server, or custom. So I started the sample app. So in the sample app, I'm just saying sample app service, number of desired tasks, 1, security group, automatically create new, application load balancer, 80 HTTP. Cluster name, default, VPC ID, automatically create new, subnets, automatically create new. We went through all this VPC and the subnets creation in the previous lecture, and you can see how easily here you don't have to do anything, automatically brings everything up for you. The whole VPC is created, the whole subnets are created, and the container. Here we are running it, so the ECS resource creation plus the default, task definition service, VPC subnet 1, subnet 2, security group, load balancer, which we are revisiting from the previous lecture. So here you can see it automatically created without you interfering at all whatsoever. But since you participated in the previous lecture, it's a lot easier to understand what it's doing. So here you can see the sample app service is running, active. It's a replica, and the launch type is FAB-IT. So that was the automation that we use. They call it FAB-IT to bring up the whole VPC for you. There are some of the things you have to do manually. I'm going to get to it very quickly. So here you have the allowed VPCs. This is your VPC ID number, allowed subnets. So you have 2 subnets, security groups, and it's the auto-assigned public IP, which we had also covered in the previous lecture. Now, when you look at it, in the previous lecture we had FAB-IT Solutions as a VPC. Now we have automatically a new VPC created as an ECS default VPC. And we have covered all these things before. But you still can have, if you have any questions, please ask. And subnets, exactly the same thing. In the previous lecture we did fits subnet 01 and subnet 02. Here we have 2 subnets again created and added to the previous subnets. Also, the routing entries. Last time we created the routing entries, we explained how they function and how you have to go to the default gateway and you have to have an external IP, all created for you. Questions?
How can I access on this machine on my browser and the public?
Same way we did last time.
Yes, over the IP address or the name?
Well, if you remember last time, we have to have we activate the public IP. This one has automatically a public IP activated.
Okay.
So you use the public IP.
If I know the public IP, I can
it gives it to
use.
you.
Okay.
It gives it to you. Yeah. But we'll get that in a second as well. Then you have the internet gateways. Same thing as last time. If you have any questions, just shout. Same as security groups as last time. So we created these security groups in the previous lecture, and now we have 2 new ones here. Any question? Now, you have your own repository here as well. So in the previous section, we had the Docker Hub as a repository. AWS offers you the repository. So you can use that repository as a service, or you can use Docker Hub. So it's up to you to make the choice. So here you can see that the images are supposed to be sitting, but I didn't create it again. This is just an introduction. Because you've done the more difficult, more complicated task beforehand, so here it's going to be a lot easier. So it's a FITS1 repository, and you just push your images into that. Now how do you do it? It also gives you an option how to push it. So you ensure you have installed the latest version of the AWS CLI on Docker. So we covered the AWS CLI in the previous lecture. And the Docker we're going to cover in a second. Then the ECR documentation. We treat the such command like, so you need AWS ECR get login to include email region to the region that you want to push. Then Docker build minus T fits01. In this particular case that we have fits01. Docker tag, you tag it. Docker push, you push it. So very similar to the previous command that we saw. Now the ECS clusters. So these are the nodes that we're talking about. On the AWS, this is very much simplified. You can have it either with auto-scaling group with Linux AMIs or without. And this thing, it's just Windows. So here we are going to use networking only. The auto-scaling we covered also in the previous lecture, which means the nodes that you're creating, if you want to automatically go up and down, it will manage it for you. You don't have to do it manually. But in this case, you have to do it manually. How are we doing for time?
26.
Past.
14. Yeah.
We have until
4. Until 4, 16.
16. And now is?
Now half an hour.
Half an hour. So the cluster one here is created and it's active. So you can here see the pending tasks, running task, active service count, draining service count, ECS instances, tasks, and metrics. So AWS makes it really simple for you, but you have to pay for it. Because otherwise you have to, construct all this, as we said, on the EC2 server. And if you have different clusters, here you have a default cluster, you have this ECS01 cluster. So if you have two different clusters, you can see them here as well. And when it comes to monitoring, this will be also useful. And that's why I mentioned that even the 3-tier monitoring is not absolutely enough to cover all your needs these days, because this is again at a different level, monitoring. So you have to go, the monitoring, you have to go with the solution that you're working on. In this particular case, AWS. So I don't recommend to have AWS, then have monitoring from somewhere else. So if you're using your IA infrastructure as a service on the AWS, the monitoring on the AWS is sufficient. Or if you're using containers, this monitoring is sufficient. Now, here we're going to go a little bit deeper into the Docker, in the data management. So you have volumes, bind mounts, and TMPFS. So volumes are stored in the part of the host file system, which is managed by Docker. Value Docker volumes on Linux. Non-Docker processes should not modify this part of the file system. Volumes are the best way to persist data in Docker. So this will be running exclusively from Docker service, from Docker process. You have bind mounts, maybe stored anywhere on the host system. They may even be important system files, directories, non-Docker processes on the Docker, or a Docker container can modify them at any time. Then you have the TMPFS, stored in the host system's memory only, and never written into the host system's file system. So they are not going to be persistent, and they will be ephemeral. Now, good use cases for volumes: sharing data among multiple running containers. When the Docker host is not guaranteed to have a given directory or file structure. When you want to store your container data on a remote host or cloud provider, like AWS. When you need to backup, restore, migrate data, and so on. Good use cases for bind mounts is, in general, you could use volumes where possible. Bind mounts are appropriate for following types of use cases: sharing configuration files from the host machine to containers, sharing source code, or build artifacts between development environments. And the file directory structure of the Docker is guaranteed to be consistent with the bind mounts the containers require. Now for TMPFS, well, there is not a good use case, just basically it's temporary. So best for using cases when you don't want the data to persist either in the host machine or within the container for quick tests. This may be for security reasons to protect performance of container when your application needs to write a large volume of non-persistent state data. For instance, if you have GDPR sensitive information that you want it to be destroyed afterwards. Any questions? Now, how does that work? We are not going to go so deep into it, but we're going to have a bit of a touch. Limitation of the TMPFS mounts. Unlike volumes and bind mounts, you can't share TMPFS mounts between containers. This functionality is only available if you are running Docker on Linux. So if you have on Windows, this is not there. Because underneath it, there are different drivers that you're loading. And in the Docker info, if you remember, you could see which driver you're loading for this particular use case. So to use TMPFS mount in a container, using ---- TMPFS flag or use ---- mount flag with type TMPFS. So here you can see we are running the Docker. We ran this before. Interactive terminal -m TMP test mount TMPFS destination app nginx latest. So we're pulling the nginx latest and we're mounting it on a temporary file system, which will be destroyed afterwards. Then we run it. To remove it, Docker container stop TMP test, Docker container rm TMP test. Persistent storage with volumes. Volumes are easier to back up or migrate than bind mounts. You can manage volumes using Docker CLI commands or Docker API. This API maybe is your favorite one. Volumes work on both Linux and Windows containers. Volumes can be more safely shared among multiple containers. Volume drivers let you store volumes on remote hosts or cloud providers to encrypt the content of the volumes to add the functionality. So encryption is also a very good aspect of the volumes. New volumes can have their own content pre-populated by a container, which you were talking about. This pre-population is not only by the image, you can do it by the volumes as well, such as the configurations. Persistent storage with volumes. systemcl status Docker, we just have a look at the Docker is running here. So we create a volume here, Docker volume create FAB-Vol. Then we ls it, so you can see the document volume in there. You can inspect it. It throws out the JSON configuration for you. Now, if you want to separately do the volume, this is how you do it. So you do docker run -p 4080, which we covered. This time we say -d for detached or daemon. And you mount source FAB-Vol, which we created previously as a volume separate volume. And we're running FAB-IT Solutions examples latest. He pulls it down and runs it for you on the volume. Now when you stop the ready sweat, it will stop, but the volume will be still persisting. In order to specifically get rid of the volume, you have to remove the volume separately.
Can I use this way to use snapshots?
Yes.
on the volume?
Yes, we're not going to cover it though, because we're already going to go all the time. There is a snapshot as well. Yeah.
Yeah.
It gets to the we could have covered the drivers as well, but I can see everybody's getting tired already.
Would it also be possible to, in this example, the first line, we start the container and attach or mount that FAB volume? If it was already running, could we also
No.
have it? Okay, only on start.
Yeah, because if you don't, then it goes to a different mode. It goes to create its own volume.
Mm-hmm.
But if you want to specifically have it on a separate volume, you have to tell it, I want to use this volume.
Okay.
Because without the volume, it will work as well.
Mm-hmm.
You'll be on a temporary memory.
Mm-hmm.
So if you don't give it a flag, it automatically goes to the memory mode. Now, whether it is possible to start it in the memory mode, then attach a volume and switch from memory mode to volume mode, I have to get back to you. I don't know about this.
It's not that important.
But it's a very good question. There's a possibility sometimes you just... I'm definitely sure you cannot export what is in memory, but perhaps... I don't know. I have to get back to you. That was a very good question. Yes, so then Docker create service, create D, replicas 2 in this case, Redis web, source FAB-Vol, target app FAB-IT Solution latest. So the first one was a syntax error, the second one is running, and you can see. Now what is the difference between this and the previous one, Faraz? We run it here and then we run it here again. What's the difference between these two sections? Peter? We are running on volumes and we are running on volumes. Why did I do this twice? In this particular case, we're not using YAML, but we're actually running 2 replicas. So this is a swarm. So this is a single server, this is load balanced.
Okay.
It's a bit confusing because...
With the same volume.
Yeah.
Okay.
So all the swarm is using the same volume.
Okay. You can share one volume for...
This is one way to do it. There's another way to do it as well.
That's very nice.
So then I have to care in the code that is running in the containers that they don't overwrite themselves. So if let's say I want each of them to have their own a log file, for example. Each of them should write a log file, what it's doing. They will all write to the exact same file, except I care for it in the code itself.
I see what you mean. So you have 5 instances. No, it's just load balancing. So your log directory will be the same, and they will be all running into the same, but you don't have to manage it.
So they wouldn't use the same file actually.
They will use the same file in the but you don't have to manage the load balancing to make sure that they don't conflict with each other.
Mm-hmm. Okay, so no conflicts on the file system itself. That will be managed. But okay, and then inside I could maybe just use the host name to distinguish between them.
And that's the beauty of it. Right now, you have problems regarding that when you have different servers, because then you have to manage it, construct it. Here you don't. All these little bits and pieces comes up when you're actually involved in a case. You can see how helpful it is. Now, this is what you were talking about. You can also have a shared file storage here. And you can have node 1, node 2, and node 3. They're all will be replicated and writing into the shared file system. Because that was an inline, this is when you have a node.
But only for the swarm.
Exactly.
Okay.
But the swarm on a node, not on a service. The service was previous one. That was a service model. This is the node model.
Okay.
But for that you have to do Docker plugin install grant all permission, SSHFS, Vux, and Docker volume create. Then you create that volume separately. Then you run docker run -d and you give the parameters. Then all your shared file will be stored in there.
This is HFS.
This is to get into your separate nodes. Because this is swarm on a node. The previous one was swarm on an inline memory.
Okay. Kubernetes.
Why Kubernetes? Why? Because it gives you a better overview, as Peter had. But generally speaking, Docker is a platform and tool for building, distributing, and running Docker containers. Kubernetes is a container orchestration system for Docker containers that is more extensive than Docker Swarm and is meant to coordinate clusters of nodes. And the scale in production, it is more sufficient. And the model that they have, you have the API server, controller manager, scheduler, and you have the users coming in for the kube proxy. You're very familiar with that. Then the kubelets, and you have your pods in here, and you have the Kubernetes nodes. And you have a plugin network like a Flannel or WeaveNet, etc. How we do it?
And the pod is the same with the Docker node.
We're going to cover it in a second. we have not much time, so we're going to rush it in a little bit. AQS Kubernetes on Amazon. You are familiar how to do it without Amazon, and you can see here with Amazon it's so simple. You basically need to have a role. You covered the roles last time. Roles can be assigned to users and services, and the policies can be assigned to just groups. So here you need a role, which is AWS Services role for ECS. And when that role is created, then you can have a Kubernetes cluster here. So this is a FITSCube version, EKS, certificate authority, and you use the role ARM to synchronize with your certificate authority to be able to use your kubectl. So then everything you do on the kubectl will be sent to AWS. And that's your cluster ARM. You have the VPC, subnets, and security groups as the Docker needs it as well. So you can see it's very parallel. How does it work? kubectl deploy static IP on the VPC. This is one of the models. You can have two different VPCs. So you have an ENI attachment. This is the only thing we haven't covered. But basically it's the network that we created on an elastic network interface. So it's not much to cover. It's basically a facility. With the ENI, you connect to your EC2 working nodes, and you have the EKS control panel up the top. And you have the load balancer here for the client. And we covered all these auto-scaling groups, static IPs, and so on. In order to deploy application into EKS cluster of the AWS, what you do is you do AWS EKS region, and name of the cluster. Then you do kubectl get SVC. Then you can have your the type of the cluster, which is SVC Kubernetes. Then you get your authorization YAML and apply the AWS auth CM YAML. So you get the authorization from the authorization screen we had before this. Then you're ready to deploy your applications. So for deployment of the application, the rest you're familiar with. kubectls might have examples. In this case, we have the guestbook, Redis master controller JSON. Then you can see the pods here, which we were referring to. So the pod is sitting here. So if you have understanding of the Docker, it's not really difficult to understand the Kubernetes. Then you have the Kubernetes create -f example guestbook Redis master. So this is your master JSON. You shoot it up. Then when you've done it, then you get services to have a look at it. So you have the Redis master, that's your cluster IP, and the ports. This seems very simple, but when you have a huge infrastructure, that is when it becomes a challenge. It's not the concept. The concept, when you understand the Docker, the concept is portable. You can relate to it. But when you have so many different clusters, you're working with it, that's the main necessity of the Kubernetes. And I always recommend the technicians to cover Docker before they cover Kubernetes. So step 3, kubectl create f example guestbook. This is a controller JSON. You shoot up. We're not going to cover the JSON this time. Just conceptually, we're going to look at it. To verify the Redis slave and controller is running, you do kubectl get rc. So you can see it's running. Then you verify the pods. You get the pods. They're running. And you create the slave service. Create -f example Redis slave. And then you get the services to look at it again. This is just a procedure of deploying the application in the larger scale. And here you've got the controller JSON. Again, you check it, and it's pushed up. Then you get the pods. In this case, you have different type of pods. So you have the get plus 3GRN, GB7i6, master, slave. So all the modules are deployed. And then you create the service. And then you look at the services, which is a higher hierarchy. You have the guestbook, Redis master, and Redis slave. And then you look at the IP, and it pops up. So on the AWS, it's very simply done. So the pods overview, you can see that the volume, containerized app, pod 1, pod 2, so they can have different looks, which different modules of the Docker that you previously looked at. And here you also can see, so you have the Docker here, the kubelet here for the node processor, the volume, pods, and the node. I think we are running out of time. This is basically a Minikube version of what you just seen, but I think everybody's too tired now. Thank you very much for your attendance.
Thank you.